Preparing for an Informatica Developer interview, you've reached Candy Mentor, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. Can you explain the Informatica PowerCenter architecture and what happens when a workflow runs? Informatica PowerCenter is metadata-driven. I design mappings in Designer, save them in the repository, then create sessions and workflows in Workflow Manager. At runtime, the integration service reads metadata, connects to sources and targets, creates reader, transformation, and writer threads, and writes session logs. The repository service manages metadata access, while the domain controls services and nodes. For troubleshooting, I usually start with session logs, reject files, and connection errors. While answering, focus on repository, integration service, domain, nodes, mapping versus workflow objects, session execution flow, connections, logs, and how metadata moves from Designer to runtime. Question 2. What is the difference between reusable and non-reusable transformations in Informatica? A reusable transformation is created once and used in multiple mappings, like a standard expression for date cleanup or a lookup used across subject areas. A non-reusable transformation exists only inside one mapping. Reusable objects improve consistency and maintenance because one change can propagate, but they require careful impact analysis. I use reusable transformations for stable business rules and keep mapping-specific logic non-reusable to avoid accidental changes across unrelated ETL flows. Make sure to cover object scope, repository reuse, maintenance impact, when reusable transformations reduce duplication, and why session-specific logic or one-off mappings often stay non-reusable. Question 3. How do connected and unconnected lookup transformations differ, and when would you use each? A connected lookup participates directly in the mapping pipeline. It receives input ports and returns multiple output ports. An unconnected lookup is called from an expression using .lkp and returns one value. I use connected lookups for normal enrichment, such as customer attributes for every row. I use unconnected lookups when the lookup is conditional or needed only for specific rows. Connected is usually clearer. Unconnected can save work, but may be harder to debug. In your answer, talk about lookup call style, return values, caching behavior, expression usage, performance considerations, and practical scenarios like validation, enrichment, or conditional lookup execution. Question 4. What is the difference between static and dynamic lookup cache in Informatica? A static lookup cache is built once for the session and does not change as rows pass through. A dynamic lookup cache can be updated during the run, so it is useful for deduplication and slowly changing dimension loads. For example, when loading customers, I can check if a customer key exists and insert new keys into the cache immediately. Dynamic cache adds overhead, so I use it when real-time cache awareness matters more than raw throughput. Be sure to mention static versus dynamic cache, cache refresh, insert update detection, lookup condition keys, persistent cache options, and memory or disk impact during high-volume loads. Question 5. What are active and passive transformations, and why does the difference matter? Passive transformations do not change the number of rows, so an expression transformation calculating full name is passive. Active transformations can change row count, row order, or transaction scope. Filter may drop rows, router can split rows into groups, aggregator reduces rows, and update strategy marks operations. This matters because active transformations affect pipeline behavior and can block optimization. In design reviews, I check active transformations carefully because they often explain unexpected counts or performance issues. While answering, define active and passive transformations. Explain row count changes, transaction boundaries, downstream effects, and examples such as filter, router, aggregator, expression, and lookup transformations. Question 6. What is the difference between a mapping parameter and a mapping variable? A mapping parameter is constant for a session run, like $src file path or $batch ID. a mapping variable can change during the session and persist its final value, which makes it useful for incremental loads. For example, I may store $last extract date after processing source data. Parameters are best for configuration. Variables are best for state. I always manage them through parameter files and clear naming because hidden runtime values cause painful production issues. Make sure to cover definition, initialization, runtime override, persistence across sessions, common use cases, parameter files, and examples such as the last run date or environment-specific path values. Question 7. How does the update strategy transformation work in Informatica? Update strategy tells Informatica what database action each row should perform: insert, update, delete, or reject. I typically derive the flag from business rules, such as change dimension attributes or deleted source records. The target session must allow those operations, and keys must support updates correctly. For upsert logic, I combine lookups with update strategy and target options like update, else, insert. The common mistake is setting row flags but forgetting target level session settings. In your answer, discuss DD insert, DD update, DD delete, DD reject, target table options, primary keys, update, else, insert behavior, commit control, and rejecting invalid rows cleanly and safely. Question 8. How would you implement slowly changing dimension type 2 in Informatica? For SCD type 2, I preserve history by closing the current dimension row and inserting a new version. I look up the natural key, compare tracked attributes, and if they changed, set the old row's end date and current flag to N. Then I insert a new row with a new surrogate key, start date, open end date, and current flag Y. I also handle unchanged rows separately. The key is accurate change detection, not blindly versioning every incoming row. Be sure to mention natural key lookup, surrogate key generation, effective start and end dates, current flag, change detection, historical preservation, and handling late arriving records. Question 9. A mapping is running slower than expected. How would you tune it? I tune Informatica by measuring first, not guessing. I check session logs for reader, transformation, and writer busy percentages to identify the bottleneck. If the source is slow, I tune SQL or indexes. If transformations are slow, I review lookup and aggregator caches, sorted input, and unnecessary conversions. If the target is slow, I check indexes, constraints, commit interval, and bulk load options. After tuning, I validate row counts and business totals. While answering, walk through diagnosis using session logs, source and target bottlenecks, transformation caches, lookup SQL, indexes, commit intervals, partitioning, pushdown optimization, and row count validation. Question 10. What is pipeline partitioning in Informatica, and when would you use it? Partitioning improves throughput by processing data in parallel pipelines. In Informatica, I choose partition points and methods like hash, key range, or pass-through based on the data and transformations. It works best when sources, transformations, and targets can all handle parallelism. I am careful with aggregator, rank, sorter, and sequence generation because partitioning can change ordering or grouping assumptions. If the database or disk is already saturated, more partitions only add overhead. Make sure to explain pipeline partitioning, partition points, key ranges or hash partitioning, database partition alignment, session configuration, ordering risks, and when partitioning can hurt performance. Question 11. When would you use joiner, lookup, or source qualifier join in an Informatica mapping? If both tables are in the same database and the database can optimize the join, I prefer a source qualifier SQL join. For heterogeneous sources, I use joiner, especially when sorted input is available. Lookup is better for enriching a large flow with reference data using key-based access. Joiner can be expensive with large unsorted inputs, and lookup can consume cache. My rule is simple. Let the database join when possible. Use Informatica when the data movement requires it. In your answer, compare data volume, sorted input requirement, heterogeneous sources, database join capability, cache cost, duplicate handling, and why pushing joins to the database is often faster. Question 12. How does the aggregator transformation work, and how can you improve its performance? Aggregator groups rows and computes values such as sum, count, min, max, or last transaction date. Performance depends heavily on cache usage. If input is sorted by group by ports, enabling sorted input reduces cache pressure because Informatica can process groups sequentially. For recurring fact loads, incremental aggregation can reuse prior aggregate cache. I still validate results against database SQL, especially with nulls and duplicate keys, because aggregate bugs are easy to miss in large batches. Be sure to cover group by ports, aggregate expressions, sorted input option, cache files, incremental aggregation, null handling, memory pressure, and verifying results against SQL aggregates. Question 13. How do you troubleshoot and recover a failed Informatica workflow in production? For a failed workflow, I first identify the failing session and error category, connection, SQL, data, permission, or mapping logic. I inspect the session log, reject files, and target counts before rerunning. In production, restartability matters. I design workflows so reruns do not duplicate data, using control tables, truncate load rules, or high watermarks. I also configure alerts and dependencies. A clean recovery design is better than manually fixing rows at 2 a.m. While answering, discuss session logs, workflow monitor, restartability, recovery strategy, commit intervals, reject files, bad rows, dependency handling, notifications, and designing idempotent reruns for production support. Question 14. What is pushdown optimization in Informatica, and what should you check before enabling it? Pushdown optimization converts transformation logic into SQL and runs it in the database instead of the Informatica engine. It can reduce data movement and leverage database parallelism, especially for filters, joins, and aggregations. I review the generated SQL before enabling it, because not every transformation or function translates exactly. Full pushdown is powerful, but database load, permissions, and semantic differences matter. I use it when the database is stronger than the ETL server for that workload. Make sure to explain source side, target side, and full pushdown, database execution benefits, supported transformation limits, SQL generated by Informatica, and when pushdown is unsafe operationally. Question 15. How would you design an incremental load in Informatica without creating duplicates or missing records? For incremental loads, I avoid scanning the full source every day. I capture only changed records using a high watermark such as last update text, an increasing key, or a CDC feed. I store the last successful value in a control table and update it only after successful completion. To prevent duplicates, I use idempotent merge logic and audit columns. Timestamps need care, because late arriving updates and clock differences can silently drop records. In your answer, cover high watermarks, timestamps versus sequence keys, source deletes, control tables, duplicate prevention, late arriving data, audit columns, and reconciliation checks afterward. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.